Little cafe we find, you smile and say, connect. I stir my tiny espresso, pretend I don't suspect. All these quiet watchers, counting every sip. I turn my screen a little, let the password slip. I want my keys in the sand, not in your hand. My secrets drifting where the tide can't reach the land. Share what I choose and keep what I am close to my chest. I want my keys in the sand, not in your hand. 1,000 voices, not just one command. We'll whisper free in a crowded room and dance in our own little bloom. You say it's for convenience, I say it feels too tight. Like every step is labeled in the soft blue light. So we carve our own small circles where trust can take its time. Pass a coated napkin with a clumsy rhyme. I want my keys in the sand, not in your hand. My secrets drifting where the tide can't reach the land. Share what I choose and keep what I am close to my chest. I want my keys in the sand, not in your hand. 1,000 voices, not just one command. We'll whisper free in a crowded room and dance in our own little bloom. Maybe control was never meant for one. Maybe the sun belongs to everyone. So write our names in scattered constellations, each tiny light its own foundation. I want my keys in the sand, not in your hand. My secrets drifting where the tide can't reach the land. Share what I choose and keep what I am close to my chest. I want my keys in the sand, not in your hand. From every corner of this quiet span, we'll whisper free in a crowded room and dance in our own little bloom.
Hello, everyone. Welcome to another week of Town Halls. I'm your host, Corey Petty. Got a couple updates. We'll start with some shout outs. JB's not here to make it. He had an appointment to make, so I'm going to do it myself. We did a video last time, but there's not enough. It's not long enough, so I might as well just do them myself. So first up, shout out to Frank from Danish. Man silently steers the ship, making sure every moving part runs like a well-oiled machine. Even when there are 100 of them, his feedback is always sharp, succinct, and actually useful. He's been nothing but encouraging and motivating to the team, and genuinely cares about what drives each of us, and that we're happy where we are. Everything you'd want in a great leader, all rolled into one. Appreciate you, Frank. Couldn't agree more. We got shout out to Maya from Balaj, Maya and People Ops. So shout out to Maya for always being there when we need her. Got Amelia. Shout out to Amelia from Chris. Shout out to Amelia for being there in the trenches, being one of the few people whose daily job is to patiently listen and talk to our community, to educate, to support, and to figure out what resonates and what doesn't. Together with the people we are building for. Thank you for all the hard work and all that you do. So yeah, big shout out to that one. It's really hard to sit and talk to the community and ask all the various questions and so on and so forth. Shout out to her. Moody and the LEE/LEZ team. Shout out to Moody and the team. The team are working on our major features such as the integration of LEZ in the blockchain, yet they have been very responsive to the red team queries, issues, and pull requests, and highly communicative. This is very much appreciated, and we are looking forward to continuing collaborating with them. That's from Frank and the Eco Dev Engineering team. So big shout out there. And Giuliano from Bellage. That's 2 from Bellage coming at you strong. Shout out to Giuliano for taking up the mantle of managing the logo storage team. It's not an easy duty, and I appreciate that it's not exactly his favorite pastime either, but he is still doing an amazing job at the end of the day. Thank you, Giuliano, for continuing to lead. So those are shout outs this week. If you have shout outs, give them to JB and the People Ops team, and we'll go over them in the town hall. And I'll also put all of those into the town hall discussion team and the People Ops channel for Discord. What else do we have here? Let's see, announcements. Parallel Societies update. We're like 2 weeks away, folks. It's coming up soon. We're going to all be in Lisbon, or for those of us that could make it that didn't have these issues and whatnot. Your IFT free ticket is available. It should be waiting in your status inbox. So make sure you have your ticket QR code ready when you're at the door for entry. We'll repeat this at the All Hands Day, but check it, make sure it works, so on and so forth. There's still time to spread the word and purchase your tickets for any friends or families or plus ones at ps.logos.co. If you haven't received your ticket, reach out to Amelia ASAP. Make sure you're all set. And we're getting really excited. It's like we're almost there. I get to hang out, see everyone, remember why we're doing all of this and who we're doing it with. These events are outstanding, and I really look forward to these. So we're almost there. If you know any developers, contacts, activists, us, people like us that want to join, reach out to Lou. She'll get you a ticket. Maybe we can get him in. So far at day one, we're at 556 attendees. That's including the coalition partners, us, core contributors, and tickets sold. We still have room. So let's get them. Let's get this place filled up. Day 2 for the festival, we have 862 people. So the more we get, the better. The better this launch is, the better people understand what we're doing. Updates there. We just added Brewster from the Internet Archive as a speaker. So that's going to be really cool to listen to. Thanks, Vaclav, for that. Some folks from Sealand will be joining. Thanks to Sterling for bringing them. And both the Jarda Mali, I hope I said that correctly, and a range of others, thanks to Agata. So anyone can get people to come. Every effort is appreciated. Let's get this thing going. It's going to be awesome. Let's see. I have 4 presentations for you today, so we'll be able to fit it in. It's going to be a full schedule. Up first, we're going to bring Constantine in. He's going to talk about a new NIM library. Here we go. And get this off the screen. Here we go. Take it away.
Hey, hello. Hope you can hear me. I'm in a hotel, so the connection is kind of flimsy, so I'm going to turn off my camera. Sorry about that.
All good for now.
Yeah, let's start. So the library I'm going to talk about today is called intops. It's a new, fresh one. It's actually the first one that I created for IFT, since I'm just a very much a newcomer in the company. And I'm going to cover what it is, why it was created in the first place. Then I'm going to dig a little into how it's structured and how to use it, and what's next for this library. So I'll be consciously not covering the specifics of the algorithms used in the library, because it's like common knowledge and there's nothing really new there. And I'll also be avoiding all the implementation details because, well, it's not that much interesting, and you can actually dig the code if you're really interested in that. I'm much more interested in sharing the path that I had to take and the decisions I had to make. And I really want to encourage people to use intops. So what is intops? Intops is a NIM library, and it implements arithmetic operations for integers. And when I say integers, I mean 64 and 32 bits, and I mean signed and unsigned flavors. When I'm saying operations, I really mean the operations that you would expect. There's addition, subtraction, multiplication, division, and a couple of combined ones, like mul-add, mul-add2, and some other flavors there. Plus, there is a special module for composite operations that are just they just combine several primitives into one for convenience. Like what it does, I mean, how it offers those operations. For each operation where it's applicable, it offers several flavors, like situating or flowing and so on. And another important feature is that it tries to pick the best implementation for any given environment. So if you're importing that during compile time on a 32-bit machine on Linux with a GCC 14, it tries to take all that into account and pick the best implementation out of many implementations available in the library. So basically what it does, it just has many flavors of many operations, and for each operation it has many implementations, and then it tries to pick the best one. I encourage you to follow those links. I've put the link to the slides on Notion so that you can dig deeper. I also encourage you to check out DeepWiki. It's a great tool to visualize stuff, and in particular, libraries. So why was it created in the first place? Why was this task actually kind of given to someone? The thing is that before intops, there was no single library that implemented operations that are, by their nature, shared among like many consumers. So because it's such a basic thing, like you got to have your addition, your subtraction. It's natural that like many libraries do that themselves within their code. But since there was no single point of truth, so there was no single library that everyone could import, like every library had to implement it themselves. So one example is Stint. It's a great library, and it had to provide a subset of operations in a subset of implementations, which would suffice for its needs. And another library, being Curve, used to import those implementations from Stint. And because Stint was never intended to be used as a provider for arithmetic primitives, Curve had to import like private modules. And by the name, you can guess that private modules are not supposed to be importable. They're not supposed to be used outside of the library. They're private. That's why they're called private. So that kind of created this weird connection between libraries where Curve depended on Stint, and Stint didn't really like want to be depended on. And like Stint developers probably did not plan to be the maintainers of Curve in this angle. Also, the operations implemented in Stint in particular, or in Curve, they were not documented in isolation from the host library. Like they were documented as part of Stint or Curve or whatever. And they were not benchmarked in isolation. So again, there are benchmarks for Stint, but there are no benchmarks for saturating addition on 32-bit machine running with like on Linux with GCC 14. There's just it's just not what Stint or any other library was created for. So like a single library that would do that and provide a single reusable interface for everybody was required. Now let's talk about how intops is structured. And this is the part where I'm talking about the decisions I had to make and the paths I had to take following those decisions. So my super top priority when developing intops was maintainability. Why is that? Why this specific priority? Well, because I think that with a library that is like performance centric and is focused around performance, there is like a never-ending chase for perfection. You cannot like finish doing this library. You cannot say that, okay, this is perfect one. Now it performs the best on all platforms. It provides the best implementation for every environment. Because things change, like what was optimal today can very well be not optimal tomorrow. Like a new GCC version is released or a new CPU architecture is kind of discovered or whatever. So this is like a never-ending chase. So this library must be extendable, it must be improvable. And this is what I'm calling maintainable in general. The second reason is that because by its nature, the library is designed to be used by many consumers, Steam, Curve, Bimbus, whatnot. I would expect that those many consumers would have many feature requests or have many yet unknown needs that will need to be covered. So that actually, with this requirement, you cannot not have a maintainable library. And finally, this is kind of trivial since so far I'm the only author of intops. Kind of the quality of decisions that are made there and the quality of implementations depends on like my expertise. So far, like the benchmarks demonstrate that the performance is on par with Stint, and we haven't seen any performance drop downs with Nimbus, and well, so far it's working well. However, there's still a risk, and I want to avoid that risk. So I don't want this library to depend on how attentive I was and like the bugs that I missed. So to facilitate that, to follow those priorities and those principles, I made some decisions very early on, and I followed them throughout development. So this is why intops looks what it is now. So the first principle was to decouple, like basically decouple things, as many things from each other as possible, because I wanted any arbitrary maintainer or contributor to be able to contribute to a single thing without touching anything else. So this is why implementations live separately from the logic that picks implementations. So we have like a special isolated place where all implementations live and a whole different place where implementations are picked. So you can experiment with implementations or with implementation choice without knowing any detail about like the rest of the library. Like the second thing that quickly popped up was that the logic of choosing the perfect implementation for a given operation should be bound to this operation. Well, initially there was like this idea that maybe there are some universal answers to universal right answers to questions like what implementation is best for a given platform. Like for example, if we can use the C intrinsics or assembly on this platform, we should use it all the time. Now, it turns out pretty quickly that this is not the case. Like each operation demands its own treatment. And so this logic is specific for each operation. Again, you can tweak a single operation in isolation, a single flavor or single operation for a particular like type, for example, unsigned int 32, without touching anything else. And finally, the logic that checks whether like a particular implementation is available is different from the logic that determines the best implementation. This could sound trivial, but it was not actually. So I had to put it in its own separate kind of a bullet point, because if we can use assembly on a particular platform, it does not necessarily mean we should use that. So again, there are no universally right answers, and therefore we have two places where we check the availability of a particular implementation. So the implementation itself checks when it's being called. It checks whether it's possible to use under given circumstances. And again, when we call the like the dispatcher, the implementation picking logic, it checks what implementation is the best for the given circumstances. Okay, a couple words about the structure. So what structure follows from those principles? You can always like get a deeper view in the docs because it's all documented there. And again, I cannot recommend DeepWiki enough. It's a great service for visualizing stuff. So if you're a visual learner, I encourage you to go there and see the library structure and all the blocks visualized there and all connections and layers. But in short, we have a submodule called impl, which basically is the home for all implementation kinds. And because we want to be flexible, those implementation kinds can be split further into flavors. So for example, we have a family of implementations in assembly. It's called inline asm. But because there are at least two flavors of assembly, we have like two submodules there, x86 and ARM64. is just an example because there are other implementations and some of them have flavors, some of them don't have flavors, but the architecture allows us to add flavors to any implementation family or add new implementation families very easily. There is a separate submodule called ops, which is the home for all operation families or operation kinds. So, for example, there's a module for addition, for subtraction, multiplication, and so on. And each of those modules contains what we call dispatchers. The dispatcher is basically a name template that encapsulates the logic of picking the right implementation. So what a particular opkind.nym file has is just a list of templates. Each template imports this module imports all the implementations that are available to it, and each template just has this branching code that picks the right implementation. I'll show you the code on the next slide, just a sneak peek there. And finally, on the upper level, with the highest level, there's the API entry point, which basically does just simply importing and exporting all the dispatchers from all the ops, all the operation families. So what that means is whenever you want to use, the happy path is just import intops, and you have all your dispatchers available to you. If you want to be particular about that, you can import ops/add and just use the additions. Well, if you want to be even more particular and just, you want to use this particular implementation and you know what you're doing, you can always import implementation from impl asm/x86 or whatever. So you have a lot of freedom here with how you use the library. There is the easiest path, but you can be as specific as you really need to. So here's how a typical template looks like. It's really straightforward. I hope it is straightforward. But we basically just do a lot of when checks and else checks and just branching. So we're just checking a lot of conditions and picking the right implementation. Typically, you'll always see the same pattern. At first, we're just checking whether we're on where we're running this code during compile time or runtime. We're checking whether it's on compile time or runtime. If it's during compile time, we're just always falling back to pure nim implementation because only this one works during compilation time. If we're running that during runtime, we have a freedom of choice. We can resort to intrinsics implementation, assembly, inline C, and hopefully more implementation kinds will come in the future. So there are globally defined constants that allow us to, quickly check for the GCC compiler, for the C compiler, whether it's GCC, CLang, or Microsoft compiler. There are convenience constants for compilation flags, so you can really compose those conditions, and I hope they read really obviously. So by just looking at the code, you can quickly understand what is happening here. So when the compiler, for example, when the compiler is GCC and we are allowed to use intrinsics, let's use intrinsics for GCC. Intrinsics.gcc, and then the carrying addition implementation that is important from there. Again, if we're on a different platform and we don't have the compatible compiler, then we fall back to pure nim implementation. So where are we now? Where is intops used at this moment? As I already said, stint. We were able to actually replace a huge portion of code from stint with just intops import, because stint used to implement, quite a few operations. So now they're all implemented in intops. Bean curve used to depend on stint. Now it does not depend on stint, and now it depends on intops, as it should, because again, bean curve needs some primitives that were previously implemented by stint. Now they're implemented in intops. And also Nimbus 1 and 2 are both now have they both have now intops as their dependencies through stint and through being curve, like it's a proxy dependency. Both of those libraries have been upgraded to depend on newer versions of stint and being curve, and those versions already do depend on intops. So what do you do if you want to use intops in your project? And I hope you will want to use it in your project. There's a quick start guide. Again, this is the best place to start. So just go there, and there's a just a few minute read. It's really simple. But again, the short version is you just require intops in your Nimble file. You just import intops. If you want to be specific, again, you want to import specific operations. And then just go to the docs and see what is available to you. In fact, you should better start with the API docs, because I'm thinking about it right now. You should first start by seeing what operations are available, if the operations you need are there, and then you would do the A and B parts. So if you're already a user or you're just interested in contributing, there is a contributor's guide for intops. And I would be really happy if someone would, report an issue or actually try and extend the library. There are guides for adding operations and implementations. Those are two separate guides, and they should be very much up to date, because I basically wrote them for myself. And I first wrote them, and then I added the operations and implementations. So there was like a dog fooding session, which proved that those documents are valid, and they do allow me to, just by following those steps, to add new operations and implementations. So yeah, if anyone wants to contribute, there are guys for that, or you can ping me on Discord, and I'll be happy to help. So what's next for intops? This is my last slide. I want to do the same thing that I've done with BN Curve, which is replace stint usage where stint is not really a dependency and is only used for its private modules. So if you're a maintainer of a library that uses stint, in particular stint's private modules, please contact me on Discord. The contact will be on the last slide. I'll see what I can do. Hopefully, I'll be able to replace this requirement, and we can lose this dependency and replace it with intops. The second thing I want to do is just use intops in more libraries. This is like the case with stint. So stint used to implement its own primitives, and now it delegates those implementations to intops. I want to do that with as many libraries as possible under IFT umbrella or outside IFT. Why not? Again, if you're a maintainer of a library that does implement its own arithmetic primitives, but you really don't want to do that, you would rather delegate that, please contact me. We can together find a way to replace that. Maybe we could extend intops with the necessary primitives, or maybe intops already covers all your needs, so you just have to lose like a good portion of your code. Next thing on the roadmap is deprecating parts of Stew. For those who don't know, Stew is like a NIM library that is a collection of various submodules that implement various really not connected things. So they're just randomly there. They're just useful, and they're too small to have their own libraries. So Stew is like this collection of things. And some things there do overlap with intops. For example, situating arith and situation arith were two tiny modules that are already deprecated because they're already implemented in intops. Like the next obvious candidate is btops module, because it's very logical and natural to implement btops in intops. Maybe there's something more there. And also, this is like the last, but it is by far not the least important. I really want to have intops properly benchmarked. Currently, intops is 100% covered in benchmarks, so all operations are tested against all targets. so we can always check which implementation is better on any given platform. So we can, use this information to tweak the dispatchers. However, currently those benchmarks run on GitHub Actions. So we have all the volatility that it provides because we can't be sure that it runs in the same hardware all the time and the same environment. So the results are currently, I wouldn't say too reliable. They're kind of flimsy. So sometimes the benchmarks would show a drop in performance where there was none actually. So yeah, we really need a standalone benchmarking stand like the one used for Nimbus benchmarks. And we've discussed that on Discord with Siddhartha, and he was eager to help with that. So hopefully we'll have reliable benchmarks for intops in the future. And by the way, those benchmarks are published to a great service called venture.dev. This is a great one. I really liked working with it. If you're not using it, I recommend you trying it out. It's just a service where you kind of publish or your benchmarks results, and it visualizes them in plots, and also detects performance degradations, and it would notify you if you have a significant degradation. It can tweak it. And there are many knobs you can turn and tweak it to your liking. But yeah, I really like the idea that you can basically publish your benchmarks for a library like intops. That's really important. So that's all for me. Feel free to contact me on Discord, where I'm at Margagu. I'll be happy to tell you more about intops or answer your questions there. And if you have any questions now, I'm happy to answer them right now.
That was great. It's certainly a library that I can see being useful for abstracting away, because of so many things use big integer operations as a core primitive. Yeah,
that's the idea anyway.
Yeah, it's certainly one of those things where you want to make sure that especially in this industry, there's so much of us use it, and cryptography for that matter. Yeah, thanks a lot. Go see him on Discord, read all the stuff. I was reading some of your forum posts. You're very helpful when people interact with you, so don't be afraid to go talk to them and learn more about it. So yep. Up next, we have, let's see, who do we want to go first? Raise your hand in the background. Jinho wants to go first. All right, Jinho, bring you on.
All right, thank you. Can you hear me?
Yep. Have at it.
See my screen as well? Okay. So, hi everyone. Today I'd like to give you an update on Logos Contribute, our contributor portal designed to support and celebrate open source contributors across the Logos ecosystem. So the goal of this portal is very simple. So first, we want to recognize the amazing work our community is already doing, and second, we want to make it much easier for new joiners to make their first contribution to the Logos ecosystem. So open source contributions can sometimes feel unclear, so you may not know where to start, what to work on, or whether your work matters. So Logos Contribute helps make contributions more visible, structured, and rewarding. So you can visit at contributelogos.co, where everything is in one place for contributions. So here you can see our contribution statistics over the last year. So we've seen consistent activity across GitHub issues, pull requests, reviews, docs, translation, and events, you name it. So what's encouraging is not just the number of contributions, but also the diversity of them. So it's not only the engineering work. So open source contributors and community members do writings, translation, and organize events. That tells us something important. Contributing to Logos isn't limited to developers only. So anyone in the community can participate and create an impact. So to help motivate and recognize contributors, we introduced a leaderboard system. So like this. So it adds a bit of fun and friendly competition, but more importantly, it gives contributors visual recognitions for their work. So you can check the current leaderboard at current contributorlogos.co and leaderboard navbar menu. So, like regarding the scoring, each type of contribution earns some point. So, for example, opening a GitHub issue, merging a pull request, reviewing code, writing docs or blog posts, translation, designing assets, even organizing meetups or giving talks. So, um, GitHub related contributions so fully automated, and we've manually like given some points to key core contributors. So we are intentionally rewarding more than just code, because open source is not only about like commits, it is about the entire ecosystem that supports the Logos ecosystem. So so Logos exists because of our community contributors across the world. So every issue reported, every PR merged, every review and translation adds the value. So we couldn't do this without the community. And now here's the important point. The contribute portal is evolving. Instead of just being a contribution tracker, the contribute portal will become something bigger and more comprehensive. So Logos contribute the current existing website will evolve into the Logos Builder Sub managed by the EcoDev team. The idea is to move from simply tracking contributions to actively supporting the community of builders end to end. So the EcoDev team will share more updates about the builder stuff later. To be specific, then what will change? So what exactly is changing? First, the proposal will be more structured and transparent through the Logos forum, forum.logos.co. Second, issues will be organized using labels across our GitHub orgs and repos, so contributors can easily discover tasks that match their interest or skill set. Beyond that, the Builders Hub will include more comprehensive features to guide open source contributors from onboarding to contribution. In short, we are making it easier to make activities more transparent and understand the context and start contributing quickly. So like I mentioned before, here's a quick look at our new proposal process. So instead of submitting proposals through Logos Contribute website, we are moving everything from the Logos Contribute to the Logos forum. Like this, there is a proposal category, so you can click on it to see existing and ongoing proposals. Now community members can simply go to the forum and post their ideas, and this makes discussions more open and transparent, and it will allow the whole community to give feedback and keep proposals in the same place. So people all over the world is helping realize the vision of Logos. So we're pioneering a new era of freedom. I mean, it is a grassroots social movement. So we need the community to build the decentralized tech stacks to revitalize civil society. So our contributors bring the values and energy that drive everything we do. So the contribute portal, which will become the builder hub, will be the gateway for anyone who wants to be part of Logos. I'm honored to be part of this movement, and We are excited to build the next phase together with the contributors all over the world. Thank you all very much.
Nice job, Junio. Good to see like us being able to highlight and keep track of what's going on and see like visualize that growth as we see people come to the project, contribute, get scores. I like the scoring system, especially the fact that you brought in more than just the developers and all the things that come around that bleed off the development is important too. Great job.
Thank you.
See you in a few weeks.
See you.
Up next, we're gonna have Philip. Philip coming in to talk about logos improvement proposals, or LIPs, if you like.
Hey there. Can you hear me?
Yep, all good.
Loud and clear. Okay, hi everyone. Nice to see you all here. I'll talk a bit about the LIPs, or the LIPs, the logos improvement proposals, which some of you may know is previously called RFCs. Now we tend to call them LIPs, or LIPs, logos improvement proposals, which are currently live on lip.logos.co. So this is how the new interface looks like. As some of you remember, the old RFC index was a bit non-interactive, not user-friendly, and so on. So we changed it from Docusaurus, which used to be the old interface. Now it's Gitbook, actually. This is still not the finalized version. I would like to call it something like a beta version. I think that's the best name for it right now. And there will be improvements to it, although it's already much better than the Docusaurus one was, in my opinion. And these are just some of the things that are now possible, which were not possible before. So basically all types of filters, sortable columns, clickable links on the sidebar, where you can actually, look at a few specs at the same time. And you can also see the template, much easily reachable through this interface. What I would also like to kind of emphasize is the possibility to see previous versions of a spec in the spec itself, which, as time goes, might be a bit more useful when we go down the development road a bit further and, specs change their versions and so on and so on. So it's basically what I would call a standard Gitbook experience, from this side. Sorry about that. So I would like to talk about the specification anatomy a bit. So you will see me and Florin more precisely commenting a bit on your specs. We are now the co-owners on this on a specific repo, the RFC index repo. So basically, these are some of the things that we will be taking a look at when we look at the new specs. So the metadata header, the abstract, the background, specification, security, privacy, copyright and licensing references. Basically, all of these are currently inherited from one COS, the first specification in the index. Although it is prone to change, we are always open to communicating, how we can improve this and what you would find, you as in the project teams would find more suitable in this kind of template. But this is what works right now. We try to kind of implement these into every specification. Our comments are purely, they're not like a must-do for you. It's basically just a proposal for when you can improve, but the ultimate decision is on the ones who actually wrote the spec. We would like to keep everything uniform, but in the end, again, everything is open to discussion. So if you want to discuss a bit more, I hope we'll be talking on the all hands a little bit about that, or you can just reach out to me directly. This is the specification lifecycle, again, based on COS or consensus-oriented specification system. Again, in use today and open to improvement. So we have raw, draft, stable, deprecated, edit, and deleted. Most of the specs that are living in, in the index, in the lip.logos.co are actually raw and draft. We don't have many, maybe just a few stable specs which are not I think even in use anymore right now, but I need to check. But that's okay. So any kind of version of a specification you would like to write, even if it's a very start and it doesn't have all the previously mentioned elements, it can always go as a raw within the index and we can work on it together. If you need support on it, feel free to reach out to us, feel free to tag us in a comment, feel free to just in Discord as well, wherever you need, you just can ping us and we can help you out with that, specifically me. So this is a life cycle. This is like what would be the happy path for a spec, although it doesn't have to be that way. It can be several months in raw, go to draft, and then go back into raw if necessary. If somebody decides that they want to work on the spec a bit further, basically, or you define some kind of additional work to be done on that. So again, cost is the process we use today, but it will be refined, probably changed as the specification process matures in the future and we have more discussions with the project teams. So this is basically what I already mentioned and how adding a new lib works. So you write a raw spec, add it directly into the index, into the VAC peer-to-peer RFC index as raw. We implement and iterate upon it. We can propose a draft status. Then we do the reviews, basically. And then if necessary, when there's a couple of implementations of that spec, we can discuss about moving into stable. It's important to mention probably that, moving into stable is a bit... it requires a bit of implementation work, so I don't think we'll be seeing that before mainnet anyway. What's next? So the index, while it's functional today, we still treat it as it is like in beta. We will, of course, shift priorities based upon what we hear from you guys and what we, find as potential bugs within the index itself. We already found a couple of ones, thanks to the people who actually reported those. We try to fix them as soon as possible. So yeah, basically within a day or two, most likely. What some things we want to do, that we want to work on basically is change notifications, how they work, integrate better search capability, to link between specs and potentially in the future between documentation as well, because we are aware that sometimes specs are not the only source of truth that exists out there. So we want to, link it to something else that is in the ecosystem as well. The dashboards can be, specifically the previous versions can be a bit better as well. And we also, as I mentioned before, want to refine the process itself. It works well enough today, but yeah, it needs to be iterated upon a bit. So your feedback is, again, very, very, very useful. Please report anything, open a GitHub issue, bring it up directly, in Discord, wherever you find most appropriate, by email. So basically, just reach out and we can work on something, especially if it's useful to your project. Okay, so some things that we want to also work on to help you out with the spec writing. Corey mentioned this a couple of weeks ago. It's the adversarial spec. It's you can see the link down there. I also shared the presentation on Notion, so you can see the whole presentation, all those that are in there basically. That's basically something that we want to provide to you guys as a tool to help with the spec writing. It doesn't have to write the specs for you, but it can help you greatly, in improving the process itself. If you find it a bit, time consuming, if it's not something that's for you, you can also kind of reach out to us and we can help you out with that. It's not live yet. I mean, the tool is live, but I want to research it a bit more and then basically edit its skill a bit to work better for us in Logos, so that we can, basically make it our tool in a way, even if you can brand it a little bit. So why not? We'll see. So basically, the end goal here is to, use the power of AI to help us write better specs, for things that are usually time consuming for you guys. Corey, do you want to mention something here? I see that you brought up on the.
I didn't even realize they were going to add more, but yeah, it's like for the adversarial spec, it's well, we would fork it so that the output of whatever the argument is between the LLMs is structured in such a way where it's spitting out documents in the format that we want them. Right now, Zach Cole had created this thing based on his process, and so he does it through what's called PRDs, like product requirements documentation, and then a technical specification, and those aren't necessarily following the costs / specification project like process we have. So just to the fact, if you use this tool and by the end of you talking about it makes sure that you have all the things that we care about and then spits it out in the right format, that's useful in itself. That's kind of like the initial flow there. But yeah, I mean, more tooling to make it easier to spit the right document out so that it gets integrated into the RFC index, and make sure you're checking off all the different aspects of it that you should be thinking about when you're writing these things. That's all.
Exactly. Yeah, thank you. key links that might be useful to you guys is the libs.logos.co, the VAC peer-to-peer RFC next to the repo itself, and the OneCOS, which is basically used for the process itself right now. And in case you have any questions, you want to raise anything, you want to talk with us, reach out to me or Florin directly, or you can just post in the RFC PM channel on VAC Discord. So I look forward to hearing from you guys. Don't be shy. We can talk about anything, even if it's bad, even better if it's good, stuff. So yeah, just reach out. Hope to see you soon.
Yeah, very near and dear to my heart. And I think we'll be having a good number of conversations at the all hands and offsite around this with leads and whoever else is interested and has opinions on what specs are and how to do them. And I think that, and what you mentioned was also something that I think is really important, is like, for every piece of documentation, how it relates to a specification is important.
Yes.
To try to surface, and like how individual projects leverage various specifications for different reasons and visualizing that type of stuff. Like, the more we can surface that, the easier it is for people to like realize how these things are actually put into practice and used.
Exactly. Specifications might not always be the central piece. They might be, they should be, but there can also be other documentation that can help it being better defined.
Yeah. Thanks. Appreciate it, Philip.
Thank you.
See you in a few weeks. All right. Last but not least, Cyprian coming in. You want to share your screen and I'll get your slides up?
Yeah, definitely. Let me check. Oh, is it built in? Or oh no, that's like an old one.
Oh, not this one.
Oh, that's interesting. Huh. Okay. There we go. I'm just going to share my screen, like not going crazy. There we go. All right. Can everyone see that?
Yep.
I guess so. All right, let's go. So we have a bit to cover today, so please bear with me. We have like 9 minutes, so it's going to be very intense. Let's go. So what's Status Network? It's a fully gasless chain based on reputation. We have network level spam protection. It's designed for 2 use cases, humans and bots. It's unlocking composable privacy. I will define what composable privacy means later, across all the apps. And we basically scaling Ethereum using Linea's open source L2 stack. It's a ZK VM stack. Why gasless? So basically gasless is a new privacy primitive. Why? Because when you have a fully gasless chain, you can unlock a bunch of different things, such as ephemeral stealth accounts and relayers, meaning you can have gasless bots and relayers that are just going to be batching the transaction, delaying them if needed, so then you can avoid timing correlations, which is a huge problem in privacy. So let's say you make a swap, then it's easy to track, like, this token started, it swapped with that, and it ended up in that account just because of timing. Here, because it's gasless, you can have arbitrary or like random execution actually over a long period of time. And so you can be like, hey, I want to make that swap, but I'm okay if it's done within the next 24 hours. And then suddenly it becomes way, way harder to actually do that timing correlation. Also, you don't have funding trails, so you don't know which account funded initially other accounts, and you don't have gas fingerprinting. So for example, for people who use like normal bots or just scripts, they have like hard-coded gas value, for example, then it can be used to track which accounts is linked to other accounts. But I think a huge unlock also is the free covered traffic. So what is covered traffic? It's basically creating a flood of transactions back and forth to the privacy layer that are actually kind of legit transactions, but cost nothing to execute because it's gasless. So then when you have your transaction coming in, they're just bundled into a bunch of other transactions. So it increases a lot the size of the anonymity sets. That literally doesn't exist anywhere. So second thing, the network level spam protection. So we're basically using RLN, thanks to the VAC, I don't know what the new name is, team, for helping us with that. That's awesome. We've been doing a lot of improvements there. So how does RLN work for Status Network? We basically use reputation as a base for, can you have access to free transactions? And basically, can you have access to private accounts? And so your reputation, which is called Karma, it's a soulbound token. you can only earn it by contributing to the network's growth, by staking SNT, by providing liquidity, by using the apps, by developing apps, by like paying sequencing tips, by making donations to the funding pool. So there's like a lot of different ways to get access to that karma. And once you have it, it's basically your reputation on the network. And that indicates the level of free transactions that you have. So anywhere from like 2 free transactions per day up to like 500,000. And it also informs like the level of governance power you have over the native yield. What is native yield? So in L2s right now, and in most chains really, they rely on gas fees as a source of revenue. The problem is that source of revenue is basically trending to zero. You look at Ethereum, you look at literally any blockchain, and you look at all the L2s, the money that they're making through gas fees is literally trending to zero. So what we decided is, well, let's just get rid of the gas and replace it by another source of revenue. It's actually 2 sources. One is value coming from the productive capital on L1, meaning every ETH and every stablecoin that is bridged to the L2 is actually used productively at the L1 level to generate yield. And basically that yield is bridged to the L2 to the funding pool. Also, all the native apps on the L2 generate fees, and those fees feed also into the funding pool. And so if you think about it 2 seconds, that funding pool grows with 2 metrics, which is TVL. So the more the total value locked on the chain, the higher the yield will be, and volume, meaning like the more activity there is on the apps, the higher the fees and the higher the revenues to the funding pool. And so congestion is not the main driver of revenue anymore. It's actually usage, which is like kind of 2 different ways to look at it. And as I mentioned, reputation, which is karma, governs the allocation of the L2 native yield. So that native yield comes from those 2 big sources, and then karma holders decide where that funding goes. Originally, that funding will go to mainly 2 like directions. One is liquidity providers, so that we ensure that we have deep liquidity on the chain. And second is, of course, app builders, so that we encourage more apps to be built on the network. What does it unlock? For humans, it unlocks private interactions with a lot of apps. It unlocks confidential yield, borrowing, swapping, fundraising, and so on. We have a free-to-use chain, so you don't need ETH to get started on it. You can have a seamless onboarding directly using session keys, meaning you can have no pop-ups, so no gas approvals and so on. And as a human, you can basically earn governance power through using that app over the actual, through using the network over the actual funding and parameters of the network. For bots, it unlocks like same confidential strategies, confidential balances, and so on, but it's also predictable execution. So basically bots pay either 0 or a flat fee to the chain, so you have no gas estimation, no price spikes. And which is super interesting, you can basically do a per block LP rebalancing at 0 cost, meaning at each block, if you want to, if you have enough karma, as an LP, you can basically rebalance your position all the time, meaning you have tighter spreads, you have more productive liquidity, and we lost less value to LVR, which is kind of a form of MEV. And you also have free DeFi automations. So you can do liquidation execution for free. You can do arbitrage, yield harvesting, compounding, etc. All that comes for free. Okay, updates on the network. I have 2 minutes left. It's going to be tight. We just open sourced Abrasax. It's the first implementation of a natively gasless L2 with built-in spam protection using LRN, as I mentioned. So go check it out. It's on our GitHub. It's already.
Don't worry about going over time. Just.
Oh, okay. I'll still go through it, and then if there's any question, whatever. The implementation has started with Gateway, which is our infra provider. Our testnet v2 public release target is early March, just in time for the offsite. So during the offsite, it's going to be kind of the private version, because we will still be testing out stuff. And then mid-March, we'll release the actual public version. If everything runs okay, which we really hope it will, then mainnet should be launching in April. We're really hoping that April is the target date. I would not be happy if we go to May or June, but yeah, let's try to make it happen in April. So in parallel to that, we're also using internal Kubernetes deployments for DevNet release, meaning we can also go faster and iterate faster on like how we manage the technical workflow that we have and the different features that we want to implement. Future work, super important. We want to work on decentralized slashing. So as you remember, we have that kind of karma token that is soul bound, that is your reputation on the network. Then if you spam the network, you can get slashed. And so you lose your reputation. So that's super important that we make that slashing decentralized. So we are working on that at the moment. Something very important also is the gasless kill switch. So for example, at some point, we get like super heavily botted on the network. So we'll have like a lot of different measures to avoid that. But let's say there's a big coordinated attack on the network, then we'll basically have a kill switch that we can trigger that makes all the transactions suddenly paying. Like you need to pay to make the transaction. So we kind of get back to like a normal blockchains working, which means that all the bots will get wrecked immediately. So yeah, that's kind of a very important feature that we want to get because it will guarantee the security of the network down the line. And then finally, we'll also have user level epochs limits, which is important to avoid, again, like some kind of coordinated attack on the network. On the different deployments that we're making, the hub is live. So please do check it, hub.studies.network. We have the API that is also live. It's called Snappy. It's a little hedgehog. We have a Karma SDK, which is the way that apps will be able to get access to the Karma level, so the reputation level for everyone. And all of that is getting updated ahead of mainnet. We have already selected our infra providers for launch, and we're basically signing the contracts and paying the invoices and so on. That's the current state. Native apps. So native apps, as I mentioned, are super important for the network, as part of their fees is going to fund the native yields. So we have already announced Orvex, which is our native DEX. We have already also announced Firm, which is our native CDP. It's a decentralized stablecoin based on Liquidity V2. And basically, if you have SNT, you will be able to mint a stablecoin. So you'll be able to leverage your SNT. We're also finalizing our native launchpad, also our native privacy layer. All that will be announced hopefully in the next month. But anyways, they will be present at our offsite, all of them. So you'll be able to ask them questions and understand better how they fit in what we're building. We also launched GUSD vaults on the L1. So quick word about GUSD. It's called generic money protocol. The idea is that you can deposit any stablecoin, USDC, USDT, USDS for starter, on the L1, and it means a new stablecoin on the L2 that is called GUSD. And that GUSD can be yield bearing if we want to, because basically we are able to bridge the yield from the L1 to the L2 from generated in the vaults on the L1. So it's a fresh new stablecoin that we're building in partnership with Aragon team. The goal is to expand to like many other L2s down the line. Important. So SNT staking is live on testnets. The Karma system is also live on testnets. We're ready to deploy them on testnet V2 as soon as we launch it, and then on mainnet. We are finalizing the Karma governance. So like, how do we govern the funding pool? This is also built in partnership with Aragon. We're working on the Karma NFTs. It's going to be super cool. It's like a bunch of little dragons that are soul bound, but you hopefully at some point you'll be able to trade their assets. So you'll have like a shiny new sword or like a shiny new like shield and so on, and you'll be able to trade that. All those assets will be unlocked at different levels of Karma. So there's kind of a whole gamification planned that we're working on at the moment. We are kind of very excited about that. Hopefully, we'll be able to unveil a bit more of that during the offsite. Also, we're bringing Bring ID for Sybil resistance. So it's a really cool new team that is building a bunch of kind of zk-TLS and zk-KYC solution. So again, we want to have like a very private chain, but we want to enable also to have a high reputation for each account. So we need to have a wide range of potential reputation sources, and ID is one of them. We also have 6 ecosystem apps already building on testnet V1 that will, again, be transferred to V2 and then to mainnet. It's games, it's privacy protocols, a bunch of cool stuff like that. TDL. So we have our pre-deposit vaults that are already open. Please do check them out. hub.status.network, pre-deposits. We have currently about 7.3 million deposited in it. About 1.2 of that is from Treasury. The rest is from depositors. So interestingly, we have LPs that could deposit up to like 20 million in ETH and GUSD. But the problem is with the downturn, like the recent downturn of the market, we can't guarantee anymore the liquid reward yields that they're aiming for. So we need to wait until we launch mainnet to be able to attract that kind of liquidity. So hopefully on mainnet we'll have like attractive yields, and then that liquidity will be able to get there. If you still have some LSNT around, or if you have like stables or ETH, deposit now. The address is here. Marketing now. So we got like pretty good tractions actually on the hub since we launched the pre-deposit campaign. About like 100K views. We on Twitter we're growing pretty well. In the sense that we're a fresh new account less than a year ago, like eight months ago or something. And so we're just growing organically. It's pretty cool to see. We get a bunch of engagements, so that's nice. And now we're launching a whole new strategy around SEO and GEO. So for those who don't know what GEO is, it's basically SEO but for bots. So meaning we create content that bots will be able to parse and use and basically showcase to end users directly through prompts. So we want to be heavily well positioned for like gasless network, for yield-based network, and so on and so on. So like privacy, etc. So we are doing like a lot of push around that area. Shout out to Camila, she's leading that. She just installed CloudBot and so on. So it's going to be fun to see how that goes. There we go. Any question?
Woo! What's the main holdback for like not launching in April?
I don't know why I have this thing here. Okay. So the main holdback, I think, is as you can understand, we have like a lot of different tracks in parallel. Yeah. And so the risk is like, for example, if the governance is not ready on time, well, we can probably launch mainnet, but then the governance will come a bit after, which is kind of fine. But let's say we have a main issue with Gateway, which is our infra provider, then probably will not be able to launch on time. The vaults, we have like a whole pipeline to like how to actually bridge the assets from L1 to L2 once the L2 is live. We need to make sure that works, right? So there's like a lot of testing going. We have also still a bunch of audits that are being made. So yeah, that's the there's no like major blocker in the sense that we kind of know what we're doing now. The main issue is we have so many different tracks in parallel that if just one derails, it can actually affect substantially the release date ultimately. So hopefully that doesn't happen, but we're like super on the lookouts. So by the way, if I take more than like 2-3 days to answer your message, it's normal. I'm like flooded. So please just ping me again. I'll answer you. Sorry about that if that happens. So yeah, it's basically like a lot of things to keep in track. And if something is not there, then yeah, it can derail a bit the timeline.
Yeah. Chris had an answer here. So thanks for updates. Dumb question. Someone asked me, why do we launch an L2 for status while also launching an L1, which also includes Logos messaging? How do we position this? And my quick answer to this, he asked for like a 1-minute answer here, right? So my quick answer to this is that what Logos is building is still in its very early phases. Like the blockchain, everything, we're in DevNets. We'll get the testnet out by all hands, but like the amount of infrastructure that is to support something that like the momentum that the status L2 currently has isn't there yet. And so while we work on the lower layers of privacy infrastructure, status can run full bore with catering to the Ethereum ecosystem and current L2 market. And we can assess how to merge those two down the line whenever Logos is prepared to handle the momentum and growth that status is currently pushing for. Like
If I can,
parallel tracks, because like the Logos infrastructure isn't ready for what you're currently pushing right now with the lineal 2.
if I can add very quickly to that, I think there's two answers. First is we are the guinea pig for the Logos launch, meaning we are basically checking everything we need to launch a new chain. So infra providers, liquidity, literally like anything like oracles, RPCs, that stuff needs to be figured out for Logos launch. And we're basically already doing that work here. So we will be able to inform a lot on the when we're ready for mainnet or even for testnet for Logos.
Yeah, it's really nice to have things like that too, because like if you look at like Nimbus as the alternative for that, for the same situation for that, for like how do you build efficient production clients for blockchains, this is the same thing for like how do you what are all the bells and whistles you need? What's the process of launching a chain? You're going through that and we're getting that experience through you.
Yeah, exactly. And second, I think is I made a presentation on that at the last offsite. I think this year I will also kind of push that again, but the ultimate goal would be to have a way to basically push our DA, so our data availability layer to Logos, ultimately to Bedrock. This way we can have kind of composable privacy also with the Logos ecosystem. And if you think about that in the kind of the longer term, we are a very Ethereum focused ecosystem. Logos is going to be its own ecosystem, but the problem of all new ecosystems is how do you get liquidity in? So we are, as Stage Network, we're going to act as the bridge between the Ethereum ecosystem and liquidity with the Logos ecosystem and liquidity. Meaning we're going to launch, like in about 6-8 months, we'll launch a new core private asset, which is ZETH, that is kind of slightly leveraged ETH that will give you like a very good yield in ETH privately. And that stuff, my kind of goal is to be able to bridge it ultimately to Logos so that we have an ETH-based yielding, like high yielding assets that is already private from Ethereum that gets into Logos. So you have kind of enough level of privacy so that when that stuff gets to Logos, it's like already pretty private.
Interesting. Yeah, it's a lot of work there, and we got there's a ton to go, but it's really nice to see you pushing along and coming headway. And I'm staked on. I've staked on my S&T.
Yeah, me too. I don't have anything else.
All right. Well, thanks, Cyprian, and that's all we have for today on everything. I have the details in the Notion page, which I'll put in the description of this YouTube video. It's also it'll also be in the IFT Townhall's discussion channel. So if you want to see all the slides from all the presentations we have today and all the links and everything, they'll be in there. So thanks again. See you in a couple weeks. See you in real life in a couple weeks.
Yay! Looking forward.
Bye.
Bye.